Hello, I'm Mr. Malden, and this is the Math Toolbox where I teach you to become a middle school math master. Today, our objective is that we're going to be able to multiply and divide integers. That's what we would like to be able to accomplish. So let's just go and get right into this. When you're multiplying and dividing integers, by the way, let's just talk about what an integer is before we start talking about these rules. There are rules, that's what I was about to say, but before we get to talking about the rules, we just need to remember what an integer is, all right? An integer is a positive or a negative, like complete number, all right? So this is an example of integers, also including 0, all right? These are all integers. By the way, when we write that, we don't have to write the positive, but there you go. There's an idea. Okay, so complete number, I mean numbers that don't have decimals. So that would not be an integer. This is not an integer because it has decimals, all right? So any number that is a positive or negative complete number, all right, including 0, those would all be integers. So the objective today is really just to multiply and divide positive and negative numbers, all right? Well, we've got some rules that go along with that. And the rules, you can see right here on the screen, is that a positive times a negative is a negative, or a positive divided by a negative is a negative. Or to say it kind of the reverse, the second line down right here, is saying that a negative times a positive is a negative, all right? Well, it's basically the first rule just kind of switched around, right? And then the final rule is a negative times a negative equals a positive, all right? So you have this situation whenever you're multiplying positive and negative numbers where sometimes you're going to get a negative solution, and then sometimes you're getting a positive solution depending on what the two integers that you're multiplying or dividing are, all right? Well, these can get, I don't know, just a little tedious to memorize. So there is a tool that I like to teach students. It's called a positive, negative, negative triangle, and it's a really easy tool to use. It's a tool that I have in my toolbox. Again, it's a really easy tool to use. It just looks like this right here, where you've got a triangle drawn out with a plus sign or a positive sign on the top of it, and then two minus signs or negative signs down below. All right. And to draw it, you can draw it as small or as big as you need to draw it in order to be able to use it. This is, how I would draw it if I were multiplying a bunch of positive and negative numbers on my paper. I might just draw the little tool down in my little corner down here. So if I had like negative 6 times 3, and then 7 times negative 4, and then let's just do negative 8 times negative 5, all right? Just like that. Well, if I had a bunch of problems like this on my paper or my work, I might draw this tool down here just in the bottom right hand corner so that I could be able to use it. The tool just kind of tells us what the rules are. If you remember what the rules are, there's the rules listed over there. And the tool, if you forget what the rules are, will tell you what the rules are. So it's just basically saying a positive times a negative is the one that's left over. And effectively, the way that I use it, I'll draw a little bit bigger so that you can kind of see it. All right. If it's on my paper and I'm multiplying numbers and I'm trying to figure out what the sign is going to be, I'm going to, cover with my fingers the different signs so that whatever's left over, that's going to be the answer. So it would look like this: a negative 6. That's this first one right here. Sorry about the glare. You can kind of not see it, but that's a negative 6, so I'd cover the negative, times a positive, so I would cover up the positive, is going to equal a negative. That's the one that's left over. So it just gives me a tool that I can put on my paper, and then I can just kind of use my fingers. I can be able to determine what the sign is going to be. All right. Well, the great thing about multiplying positive and negative numbers is you already know how to multiply the numbers, or you should at this point. And that's the first step. Whenever you're multiplying positive and negative numbers or dividing positive and negative numbers, the first thing you're going to do is just worry about the numbers. So in this case right here, 6 times 3, that's 18. All right? And then you'll worry about the sign. All right? You'll be concerned with that. So I've got a negative times a positive. So I'm going to cover up my negative here. I'm going to cover up my positive right there because I have a negative times a positive, and the one that I have left is this one that I'm not covering up. It's negative, so the answer is going to be negative. And if you go back to the rules, all right, the rules say that a positive times a negative equals a negative, or in this case right here that we did, a negative times a positive equals a negative. So you can kind of see that that it's worked out. All right, the tool has helped us understand what the answer is going to be. All right, let's go ahead and move on down. Let's look at this 7 times negative 4. Well, you have 7 times 4 first is 28, right? And then you have a positive times a negative. So we're going to go to our tool. We're going to cover up the positive. Positive times a negative, so we're going to cover up one of the negatives, is going to equal what's left over, a negative, all right? Just like that. So the answer is going to be negative, all right? I drew like a little curvy negative. There we go, all right? And then finally, we've got this last one, all right? Again, all we're worried about to begin with is just the multiplication of the numbers. 8 times 5 is 40. Okay, and we have a negative times a negative. So we're going to see on here a negative times a negative equals, which one's left over? The positive is. So the answer is going to be positive, just like that. So really not an incredibly hard concept, especially when you use a tool like this, all right? It can become pretty easy. So I'm going to give you a chance to try these, all right? So you can pause this video if you want to. You can try all of these. There you go. On your scratch sheet of paper, and then unpause the video, and we'll come back and tell you what the answers are. All right. So I'm assuming that you paused it now, and I'm going to go through what the answers are. So the top one, we've got 5 times negative 7. All right. So first thing we're going to worry about is 5 times 7. That's 35. And then we could go to our tool. Let me erase my board. We could go to our tool, which is positive, negative, negative triangle. 5 times negative 7 equals, well, 5 times 7 is 35. And you've got a positive times a negative. So you're going to cover up the positive, one of the positives, cover up one of the negatives, and what do you have left? All right, we have a negative sign left. So that's going to be what the product is going to be. All right, so 5 times negative 7 is negative 35. All right, and then we next have negative 5 times negative 7. Again, 5 times 7 is 35. But now we have 2 negatives being multiplied times each other. So we'll go to our handy-dandy little tool. Negative times a negative is a positive. And so that's our answer, is positive 35. And then finally, we've got negative 6 times 8. 6 times 8 is 48. And a negative times a positive, all right, is a negative. All right, so the answer is going to be negative. All right, hopefully that's pretty straightforward to you. Right? Then we've got, so we've got our answers there. Let's go to the division, all right? Still the same concept, all right? First thing you want to address is the division of the numbers, and then you want to address what sign is it going to be. So in the case of 45 divided by negative 9, 45 divided by negative 9, all right? And again, if you haven't paused this already and tried to do it on your own, you should do that. Go ahead and pause it, all right, and then come back and see what the answers are. All right, so 45 divided by 9 is 5, all right, and we have a positive divided by a negative, all right, so I'm going to use my positive, negative triangle to see what the quotient is going to be. A positive, so I'll cover that up, divided by a negative, so I'm going to cover that up, is finally a negative, all right, just like that. Right? So it's a great tool to be able to help us understand really quickly, if you're ever confused, what the answer is going to be whenever you're dividing or multiplying negatives. You could use a positive, negative, negative triangle. All right? Do not use this positive, negative, negative triangle when you're adding something. So if you were doing negative 6 plus 5, you don't want to use the positive, negative, negative triangle because it's the wrong tool to use for that. For this, I like to use a tug line. All right? Which, if you haven't watched the video yet for adding integers, you might want to go back to watch that. I'll teach you how to use a tug line like this, where you'd put like the negatives on team negative and the positives on team positive. And then is there a war? Yeah, so you have to subtract. And what's the greater team or the bigger team was the negative, so the answer was going to be negative. All right, the tug line's good for adding positive and negatives. All right, don't use the positive, negative, negative triangle. Right, for adding. And for subtracting, you want to apply keep, change, opposite, and you'll be able to add. But again, you can go back and watch that on the adding integers video. Let's go to the next question. The next question was negative 63 divided by negative 7, all right? And again, we're just going to divide the numbers. 63 divided by 7, that's 9. And we have a negative divided by a negative, which is going to give a positive quotient. And then finally, negative 96 divided by 12. 96 divided by 12 is 8, all right? And we have a negative divided by a positive. So we're going to go here. A negative divided by a positive is going to be what's left over, and that's a negative, all right? It works just like that. So hopefully those are really straightforward to you. Now let's just go ahead and talk about a couple of extra properties of math properties, all right? So that you know that. The homework, if you're one of my students, then you've got some homework tonight, and it has some of this where you have to recognize which property you're using. So the properties that we're about to talk about, first of all, what is property? Property just means a rule, all right? So a property, a math property, is a math rule or a math law, okay? And all the ones that I'm going to be addressing in this video are ones that are pretty straightforward. The only one that's may not be as common sense is the distributive property. We'll talk about that in a second. But these ones right here, by the time you get to middle school math, you already understand these concepts, all right? But now you'll understand that the common sense that you have has a name, all right? So like this additive inverse property, this math law that we call additive inverse, it really is common sense, all right? You already know it, but now you'll learn that you have a name. And it just simply says that a number plus its opposite is always going to be 0. So 7 plus negative 7, the answer is going to be 0, all right? Number plus its opposite, when you add it together, you're going to get a sum of 0. Next one down, negative 5 plus 5. What is that going to equal? Again, yeah, that will equal 0, all right? And then the final one down here is, what number can I add to negative 8, all right, in order for the answer to be 0? Well, the only two numbers that you can add together for the answer to be 0 is going to be opposites. So the opposite of negative 8 is positive 8, all right? And there's the math law right there, kind of all defined out. It says the additive inverse of a number is what you add to a number in order to create a sum of 0. Okay, so let me just give you an illustration here. All right, if you had this expression, 9 times negative 6 plus 6 equals 9 times 0, what math law are we illustrating with this equation right here? All right. Well, if you look at the two expressions on either side of the equation, the only thing that's different between the two of them is this part. All right, the inside of the parentheses. We've gone from negative 6 plus 6 to simplifying it to just equals 0. So the only thing that's different is what's on the inside of the parentheses. So we've just simplified the inside of the parentheses, and the math law that we used is this additive inverse property, all right? The additive inverse property says if you add two opposites, you're going to get an answer of 0, and that's what we've illustrated right here in this example, all right? Let's move on. The next property, it's called the zero property of multiplication. By the way, if you just go back to the additive inverse property, all right, and you're ever wondering, like, okay, you see those words and you're just like, I don't know what that means. Just kind of walk through it step by step. What does additive kind of sound like? Kind of sounds like adding, all right? Inverse, that means opposite, all right? So the adding opposites law says that if you add opposites, it's going to equal 0. Likewise, if you go look at the next property we're going to talk about, the zero property of multiplication, you probably could just like look at the title, kind of guess what you think that might be. And that's just simply that if you're multiplying anything by 0, you're going to get an answer of 0. And again, that's common sense, But that common sense is common sense because it's a math law, all right? And that math law has a particular name. It's called the zero property of multiplication, all right? So again, 5 times 0 is 0, and the law that we are illustrating with that equation is the zero property of multiplication. 0 times -7, that's going to be 0. What number am I going to multiply 8 by in order to get 0? 0, right? So we're illustrating here with these different equations right here, this property. The zero property of multiplication states that any number times 0 has a product of 0, all right? So again, if you were looking at your equations, all right, and asked what math property are we illustrating with this? Well, what's changed right here is almost completely. We've just simplified this expression over here. 9 times 0 is 0. This is the zero property of multiplication law. All right. Finally, the distributive property. All right. I'm going to go ahead and fast forward through all the animations and get to the definition first. Because I think the definition, reading the definition first here is really helpful. So it says the distributive property lets you multiply a sum, right? So if you look inside the parentheses, you see there's addition going on here, addition going on here. The answer to an addition problem is called a sum. Oops, sorry. It's called a sum, all right? The answer to a subtraction problem is called a difference, but we can change this to an addition problem by just applying keep change opposites. So it still applies to this. The distributive property applies to either a situation where you've got a grouping on the inside that's being added together or a grouping on the inside that's being subtracted. Right? But it's saying a distributive property lets you multiply a sum by multiplying each addend, that's the numbers that are being added, those are called addends, all right, separately, and then add the products together. All right, well, we're illustrating this with these particular problems, so let's just kind of back up, all right? You have, let's just tackle this first one right here, 5 times 2 plus 3, all right? I'm going to rewrite that. I got 5 times 2 plus 3, all right? Now, if we were applying PEMDAS, all right, we would simplify this parentheses first. All right, 2 plus 3 is 5. Bring down what we haven't touched yet, and then we would go ahead and do the multiplication. All right, the answer to that is going to be 25. But let's apply it differently. Let's use the distributive property here, and let's just kind of understand this first. All right, what we're saying here in this expression is the number 5 being multiplied. Where do you see multiplication? Whenever you see a number next to a parentheses without anything in between, there's a default operation inside there that is just invisible. In math, a lot of times we like to be able to write things shorthand, right? Because we have really long expressions that we want to kind of shorten. And one way we do that is by making the invisible operation or multiplication invisible at times, where we just put a number next to a parentheses, or we could put a number next to like a variable, right? That's just saying we're multiplying those two numbers. You can't put a number next to a number and call that multiplication because that just looks like 23, and that's what we use to write 23. So if you're writing a number times a number, all right, you'd put the number next to a parentheses. You see that number's next to the parentheses right there? There's an operation there. It's just invisible, and the operation is multiplication, right? So whenever you have a number next to a parentheses, you're multiplying here, all right? And if you've got something going on inside the grouping, like addition or subtraction, you've got to understand, I've got to multiply that number times everything, every addend in that parentheses, and keep the operation in between them. So expanded form would look like this, all right? By the way, I always recommend every single one of my students, whenever you see a number next to a parentheses, draw arrows at the top, all right? Helps you know that we're distributing that multiplication to everything inside the grouping, all right? So that's why we call this the distributive property, all right? So I'm distributing that multiplication to everything. So the expanded form looks like this. 5 times 2 plus 3 is the same thing as 5 times 2. That's the first multiplication. Now see a plus sign here, so I'm going to put a plus in between each of these multiplications I'm going to do. And then 5 times 3, just like that. All right? So 5 times 2 plus 3 is the same thing as 5 times 2 plus 5 times 3. And if we simplify this on down, 5 times 2 is 10, plus 5 times 3 is 15. We add those two together, we would get 25. We already knew what the answer was, 25, a second ago, because we used PEMDAS to be able to simplify those. But this kind of concept helps us to be able to multiply and simplify expressions that involve variables, just like this right here. So we usually don't apply it to situations like this because we would want to simplify the parentheses first. And if you've got two constants, 2 plus 3, you can add those two together. But if you got this situation right here, the next one down, 2 times x plus 4, so let me write that on my board. All right, 2 times x plus 4. You know, when we go to the parentheses or the grouping right here, we can't simplify that because we don't know what x is, all right? But we can simplify this whole expression because even though we don't know what x is, we know from the distributive property that we can distribute that multiplication of 2 times everything inside the grouping. So again, I'm going to draw my arrows just like this, all right? And I'm going to multiply my 2 times my x. Keep my add, my addition. By the way, if this said subtraction, we would make that subtraction right there. But this is addition, so I'm going to make it addition right there. All right? And then I've got the 2 times the 4, just like that. So 2 times x plus 4 is the same thing as 2 times x plus 2 times 4, which means we can simplify this now. 2 times x, we can write it shorthand as just 2 x's. Keep our plus sign. And then 2 times 4 is 8. So this is really that right there, 2x plus 8. And that just looks a little bit more simplified than that right there, and that's why we like it to go ahead and apply the distributive property so that we can make our math sentences as short as we possibly can. All right, let's take that last one, which is 3 times y minus 2. 3 times y minus 2, all right? And I'm going to make the whiteboard a little bit bigger. Okay, so again, we're going to apply the distributive property to everything on the inside of the grouping, right? Because this is a multiplication here, so we have that 3 times everything in there. So 3 times y minus 2 is the same thing as 3 times y. Now we have a subtraction here, so I'm going to keep my subtraction, all right? And then I'm going to do the 3 times the 2 right there. And I'm just writing in the expanded form, and then I can simplify from here. 3 times y is 3y's. Keep our subtraction, and 3 times 2 is 6, just like that. So this simplifies to that using the distributive property, okay? All right, so those are the 3 properties that we're kind of talking about today. Finally, I just wanted to address substitution property. All right, there's the bell. Always going into the bell. But whenever you're substituting the values of variables, a lot of times we do this when we're checking our answers. Maybe we've solved a 1-step or 2-step equation, and then we want to go back to see if we're correct, all right? Well, here's some examples right here. Sometimes you have a key that's given to you. It tells you that one variable, the variable p, equals 4, and then another variable, the variable s, equals 2. So use those values, particular values, when you're simplifying expressions, all right? We can substitute the numbers in for our expression. So if p times s, all right, or if they have an expression p times s, if p equals 4 and s equals 2, what would the answer be? Well, I'm going to substitute using parentheses, all right? That p was a 4, so I'm going to substitute a 4 here. Keep my multiplication. And that s right here was a 2, so I'm going to substitute that in there. And I've got 4 times 2, that's 8. All right, so if we have an expression p times s, and we're told that p is 4 and s is 2, we just simply substitute those values in for the variables, and we do the math that we see. All right, just like that. All right, the next one down was p times negative s. All right, so we've got 4 for p times negative 2 for s. All right, and 4 times negative 2 is going to be negative 8. All right, and then finally we have p divided by s, okay? That's the same thing in the situation where we know that 4, it could be substituted for p. That's that's a 4, right? And 2 could be substituted for s, all right? And then it looks like a fraction right here, but just remember, jog your memory that the operation for a fraction is division. So this is like saying 4 divided by 2, and that answer would be 2. So again, we addressed in this video multiplying integers, dividing integers, the rules for that using the positive, negative, negative triangle, like that. And we addressed some different math properties and then also substituting numbers in for variables. I hope you have a great day. We'll see you next time.